Okay, everybody, we are going to take a look at the solutions to problems number 6 through 10. So we'll start off with the first one, pretty simple and straightforward problem. Number 6, what is the maximum power consumption of a 3-volt portable CD player that draws a maximum of 320 milliamps of current? So our known values are the voltage, 3 volts, and the current is 320 milliamps, which we do have to convert to amps. So 320 milliamps will equal 0.32 amps, and we are looking for the power. So we know that the power is equal to the current times the voltage, P equals IV. So 0.32 amps times 3 volts should give us 0.96 watts. Problem number 7, they're asking us to determine the resistance of and the current through a 75 watt light bulb connected to its proper source voltage of 120 volts. And part B wants us to do the same thing for a 440 watt bulb. So we'll do part A first. We are given the power at 75 watts. We're given the voltage, 120 volts. And we're being asked to find both the resistance and the current. Now remember, one thing about Ohm's law is you have 4 variables. We have the voltage, current, resistance, and power. If you know any 2 of those, you can find the other 2 using V equals IR or P equals IV or some combination of the 2 of those. So to find the resistance when we are given the power and the voltage, the resistance is going to equal V squared divided by P. So 120 volts squared divided by 75 watts is going to give us 190 ohms. To find the current with the power and the voltage, we divide 75 watts by 120 volts, and that is going to equal 0.63 amps. Seeing how we had gotten the resistance in the first part, 190 ohms, we could have used V equals IR, solving that for I, because we had the resistance at that point. So there's more than one way to solve for the current at this point, but we just kept it with our known values of the power and the voltage. But I certainly could have done that by taking the voltage and dividing it by the resistance, and I would have gotten the same answer. So for part B, we're going to do the exact same thing. We're just going to replace the wattage of the bulb from 75 watts in the first part to 440 watts for the second part. Our voltage remains the same at 120 volts. We're still looking for the resistance and the current. So I'm going to use the same formulas that I used before. R equals V squared over P. So 120 volts squared divided by 440 watts will now give me a resistance of 33 ohms. And for the current, I'm just going to take the power and divide that by the voltage. 440 watts divided by 120 volts is going to equal 3.7 amps. And again, I could have used V equals IR, so solving that for the current would have given me the current equals the voltage divided by the resistance, and it would have given me the same answer at 3.7 amps. So either way is perfectly fine. There's usually more than one way to do it because you have 4 variables total, and there's more than one way to solve for one of them. Number 8, 115 volt fish tank heater is rated at 110 watts. They want you to first calculate the current through the heater when it is operating, and then find the resistance. This is exactly the same as the previous problem, only this time I'm only making you do the calculations once instead of twice. I'm getting soft in my old age, and you guys know that I hate that. But let's take a look at this one. We're given the voltage, 115 volts, the power, 110 watts. To find the current, we are going to divide the power divided by the voltage. So 110 watts divided by 115 volts will give me 0.96 amps. To find the resistance, as we did in the previous problem, we're going to divide the voltage squared by the power. So 115 volts squared divided by 110 watts is going to give me 120 ohms. Problem 9. How many kilowatt hours of energy does a 550 watt toaster use in the morning if it is in operation for a total of 15 minutes? Now, these power problems can be a little bit tricky, but they're really just dimensional analysis problems. It's really just about unit conversion. So we're given values in specific units, and we want to convert them to specific units. In the case of this problem, we want to find the energy, but we want that energy to be given in kilowatt hours. We're given the power of the toaster in watts, 550 watts, and we're given the amount of time it's being used in minutes, 15 minutes. So we want to convert the watts to kilowatts. 550 watts is going to equal 0.550 kilowatts. And the time, 15 minutes, is equal to 0.25 hours. Now, to find the kilowatt hours of energy, simply need to multiply the kilowatts of power times the amount of time in hours that it's in operation, because energy is going to equal power times time. So 0.550 kilowatts times 0.25 hours is going to equal 0.1375 kilowatt hours, which we need to round to two significant figures. So that's 0.14 kilowatt hours. It's really just about going from one unit to another. So in this problem, we went from watts and minutes to kilowatts and hours. For the second part of this problem, it says at a rate of 9 cents per kilowatt hour, estimate how much this would add to your monthly electric bill if you made toast 4 mornings per week. So what units are we starting with? What units are we ending with? Well, we're giving the cost per kilowatt hour. We're given 9 cents per kilowatt hour, which we're going to convert to dollars. So the rate is $0.090 per kilowatt hour. And we want to know how much does it cost per month. So we want to end up with dollars per month. So we're going from dollars per kilowatt hour to dollars per month. So we know that the rate is equal to the cost divided by the energy. And if we want to know the cost per month, we want to multiply the rate by the energy usage. So the rate is 9 cents per kilowatt hour, right here. Now I know how much it's going to be costing me per day, so I know the rate is 0.1375 kilowatt hours per day. I got that in the first part of the problem. And I know that there are 4 days, we're making toast 4 days a week. And we know that there are 4 weeks per month. I know there's not exactly 4 weeks per month, but again, in my never-ending quest to make physics easy for you, you are welcome, that we're just going to use that standard of 4 weeks in a month. So let me just switch the pen here. There we go. So let's take a look and see what we can cancel out in terms of our unit conversions. So I have kilowatt hours here. I have kilowatt hours here. Those can cancel out. I have days here and days here. Those can cancel out. I have weeks and weeks here. Those will cancel out. And I'm left with dollars per month. So I know I have my unit conversions set up correctly, and I just need to do the multiplication and find out what my ending value is, which is going to be $0.20 per month, or 20 cents per month to make toast 4 days a week. Problem 10. At 9.5 cents per kilowatt hour, what does it cost to leave a 25-watt porch light on day and night for a year? This is another dimensional analysis problem. So we need to look at what units we're given at the beginning and what units do we want to end up with. We're given the rate at which we're paying for the electricity, which is going to be 9.5 cents per kilowatt hours. So we're going to mark that in dollars per kilowatt hours. And we are given the power consumption of the light bulb, which is 25 watts, which we also need to convert to kilowatts. And we want to know how much does it cost to leave it on for the year. So we are looking for dollars per year. So in order to find the cost of the energy to use this for a year, we have to multiply the power that the light bulb is consuming in kilowatts by the number of hours that it's going to be used times the rate per kilowatt hour that we're paying for the energy. So we're looking for the cost. And I know that the rate equals cost divided by the energy, which means that cost equals the rate times the energy. And I know that energy is equal to power times time. So the cost is going to equal the rate times the power times the time. So my rate is in dollars per kilowatt hour. So I'm going to multiply that by the power consumption of the light bulb in kilowatts. So 9.5 cents per kilowatt hour times 0.025 kilowatts. And using my dimensional analysis, I know that the kilowatts are going to cancel out. So now I'm left with dollars per hour. So I want to end up with dollars per year. So I have to just convert from hours to years. So in order to do that, I'm going to find out how many hours are in a day. I know that there are 24 hours in a day. That makes my hours cancel out. And I know that there are 365 days in a year. So my days will cancel out. And I'm left with dollars per year, which is what I want to end up with. And when I do the math out, I'm going to end up with $21 per year to leave a 25 watt light bulb running day and night for the entire year.